So we're going to look at the investigation. If you have your textbook there, you can turn to page 496 and you'll be able to see this much better. It's very small here so that I have the ability to still write on the screen. I might actually be able to get away with sliding it over and making it a tad bit larger, but it's, even if I make it larger, it's still pretty blurry. So, but we'll see what we can do. So the first part says we have a function, and our function is f of x equals the sine of x, okay? So take your calculator, your graphing calculator, and go ahead and put the function f of x equals the sine of x on your function. So there's mine on my Inspire. Okay, so that's my sine function, and the problem itself said to graph it between negative 2 pi and positive 2 pi. Okay, so I'm going to put this, actually, they have it here for you as well, but I'm going to put this on my graph paper down here. I'm going to call this 1 up here, and sugar. I'm going to call this negative 1 down here. Okay, and I know that my sine function is 0 here. It is 1 there. It is 0 here. It is negative 1, 0, 1, 0, negative 1, 0. So that's my original sine function. What we're going to be working on is graphing the derivative of this sine function. That got a little wonky, didn't it? Let me go back and I think I thought the number 1 was a point. I think that's what I was shooting towards when I was drawing. So we'll go up here. There we go. That's much better. There we go. All right. So this is f of x. Okay, that's equals sine of x. So it says there are 4 values where the gradient of the tangent line, slope of the tangent line, oh, derivative, right? Slope of the tangent line, derivative, great. The derivative is equal to 0. What are they? Well, the derivative is equal to 0 when we are at a maximum or a minimum, right? So we have 4 of those. Do you agree with that? Okay, so for number 1, we're looking at t equals negative 5 pi over 2. 5 pi over 2. I'm sorry, that's not a 5, that's a 3. Negative 3 pi over 2. Let's try that. And negative pi over 2. And positive pi over 2. And positive 3 pi over 2. Okay? So we've got those values. We're going to use, what are they? Use these values to plot 4 points that are on the graph of the derivative function. Well, we said the derivative is equal to 0 at these points. So I'm going to go ahead and put this in orange. This will be my derivative. So my derivative is equal to 0 at those points. Okay, so I plotted those 4 points. Great. So now in number 2, it's asking us to list the intervals between pi and negative 2 pi and negative 2 pi for when the graph of sine of x is increasing and those where it's decreasing. Okay, so we kind of want to, in order to do that, we want to look at this graph. This thing is increasing here, right? So for number 2, we're going to say increasing from negative 2 pi to negative 3 pi over 2. The second place it would be increasing is starts here and goes up to there, right? So that's negative pi over 2 to positive pi over 2. So negative pi over 2 to positive pi over 2. And the third place it's increasing is from 3 pi over 2 to 2 pi. 3 pi over 2 to 2 pi. Okay? And then it's decreasing in 2 areas. it goes from negative 3 pi over 2. So it's decreasing from here to here. So that goes to negative pi over 2. And it is also decreasing from pi over 2 to 3 pi over 2. To 3 pi over 2. Now, if our original graph is increasing, what that means is our derivative is positive. So that means our derivative will actually fall above the x-axis in that case. So it would fall above here, okay? If our original graph was decreasing, so if I put a G on it, if it was decreasing, which is doing between these 2 points, that means my graph is going to be below the x-axis. Again, it's increasing between these 2 points, so it's going to be above the x-axis. So what it then says, when f is increasing, what is true about the sign of the derivative, okay? So when it's increasing, the sign of the derivative is positive. When it's decreasing, the sign of the derivative is negative. So this would be the sign of the derivative is positive. The sign of the derivative is negative. Okay? Use this information and the points you plotted in question 1 to make possible sketch of the graph of the derivative. So we said this thing here is going to be below the x-axis, right? So let's say it's going to be below the x-axis, like that. And we said because we're increasing from here to here, it's going to be above the x-axis. It's decreasing here to here, so it's going to be below. And then that's going to be above. And that's going to be above. So we made the possible sketch, right? Great. Now we want to use the calculator to graph the derivative of the sine of x. So that's what I'm going to do. So I'm going to go back here. I'm going to show you real quick. I hit tab and how to put the derivative into the TI Nspire. So we use this button here, the one that says that has the template button, and we find the derivative. The first derivative looks like this, right? That's the second derivative. And then we can do derivatives of any number we want there. So we're going to do the first derivative. And we're working in x. And you know what I forgot to check? I forgot to check if I was still in radians. So let me make sure I'm in radians. I am. Great. All right. So then I want to do the derivative of the sine of x. And it's that simple to get a derivative graph. I didn't even have to come up with the equation for the derivative. Well, it was going to be that simple. But it looks like it took away my derivative symbol. Let's try that again. The derivative, x trig sine x, and graph it. And that was the graph that we just made, right? Okay. Anybody seeing anything that they're cluing into yet? Hopefully. But if not, it's all right. We'll go through it. So, be sure your graph is in radians. We did that. Compare the graph of derivative on your calculator to the one you drew and adjust your drawing. So we're good with this drawing. It looked like that. Make a conjecture, basically an educated guess, based on the graph of the derivative of the sine of x. What function do you think is the derivative? Well, what is this orange function? If I just saw this orange function out there, I should be able to come up with an equation of that just from being familiar with it. Hopefully, you're seeing that that is the cosine function. Remember, cosine of 0 is equal to 1. Okay, and it goes down from there. Okay, so let's go ahead and verify that guess, basically, with the table of values. So I'm going to go back to my TI Nspire here, and I'm going to look at my table. So I want to hit Control. I don't know if I can do it on my keyboard or not, but I can do it up here. Control T. And there's my table. Okay, and there's my sine, and there's my derivative of sine, right? So wow. Oh, because they're just growing. I gotcha. So one way to check is that we know that sine squared plus cosine squared should equal 1, right? So if we take this number, for instance, here, I don't know why I'm all the way at that point. I'm all the way at negative 600 something. Let's go back to some normal values. Let's look at 2. If I take 0.034899, that's got to warm up. Basically, I can check these, but what I should be seeing is that the sine of this squared plus the cosine of that squared should both equal 1. I'm questioning because they don't quite look right. Let me go back to my graph and just make sure. This point here. Yeah, we're in the right places. 1, 2, 3. 1, 2, 3. Okay. So I'm good with where we are. I think what would help me actually see it is if I changed my window a little bit and I actually looked at, instead of looking, it's got me jumping up by an auto X scale. Let's change that. I wonder if I can just change it to whatever I want. Let's go up by pi over 4. Let's do pi over 4. So we're going to say pi divided by 4. And hit OK. That's much better. So now each one of these little things is a pi over 4. That makes much more sense to me, instead of counting by ones. I'm not used to working in integers when we're talking about radians. So, all right. So basically, the point of this exercise was to show you that the derivative of sine is cosine. Okay? So we're going to come back here, and we're going to say that dx of the sine of x is equal to the cosine of x. When you're taking the derivative, it's that simple. If you're taking the derivative of sine x, it's going to equal cosine x. Okay? And then we're going to get into some, real quick, these are your derivatives. They should be in your formula packet. Very simple. So, if my original function is the sine of x, then the derivative of that function is the cosine of x. If my original function is cosine, the derivative is the negative sine, so that basically slides it and flips it. Remember, the negative flips it over. And the derivative of tangent, and this turns out this way because tangent is sine divided by cosine, the derivative of that is 1 over cosine squared. Because if we did sine x over cosine x and we were looking for the derivative, we would have to do the quotient rule to get it. So that's why that works out that way. All right, so the next video we're going to get into some actual problems of finding the derivative of some trig functions.